Hi, today we'll discuss LeetCode problems number 2, add two numbers. We're going to develop two solutions step by step. First, we'll use while loop in our solution. And second, I'll show you how to transform the while loop into a recursion. At the end, we'll compare the performance of both solutions. You're given two non-empty linked lists representing two non-negative integers. So here you have two non-empty linked lists, L1 and L2. The digits are stored in reverse order. So for example here, the 2, 4, 3 represent the number 3, 4, 2. And here 5, 6, 4 is the integer 4, 6, 5. So when we represent this integer in the linked list, the digits is in the reverse order. So the 2 in the integer is on the right side, but in the linked list is on the left side. And each of their nodes contains a single digit. So here in each node, the digit has to be from 0 to 9. Add the two numbers and return the sum as a linked list. So here it asks you to return the sum also as a linked list. It doesn't say the order of the linked list, so we just assume that we will return the sum also with the reversed order linked list. Let's look at the example number 1. So here 243 is the integer 342 and the 564 is integer 465. So instead of we add these two integers, it asks you to add these two linked lists. So here 2 plus 5 equal to 7 and 4 plus 6 equal to 10. So we have 0 here and we have carry 1. And the 3 plus 4 plus 1 equal to A. So here in our answer, the 807 is also returned as linked list, but in the reverse order. Let's analyze the problem with example number 1 by adding the two numbers in the mathematical way. So for example, we have 3, 4, 2. It's the first number in our example. Then we have 4, 6, 5. So the equivalent linked list representation is 2, 4, 3. And the second number is 5, 6, 4. So when we add up these two integers, we will go from right to the left. So the first digit is ones digit, and the second digit is tens digit. The third digit is hundredths digit. So first we will add up the number from the ones digit, which is 2 and 5. Here 2 and 5 is equal to 7. And the second, we add the numbers in the tens digit. So 4 plus 6 is equal to 10. Because it's 10, but in our answer, we write a 0 here, and the 1 is carried over to the next digit, which is hundredths digit. So we put 1 here. Next, we will calculate the numbers in the hundredths digit. So here we will add up 3 and 4 and 1, which gives you 8. So this is a technique we are used to add two integers. And we can apply the same technique when we add numbers in the linked list. So in our linked list, the 1st digit is on the left side, and the 10th digit and 100th digit. So when we add up the numbers in the linked list, instead of go from right to the left, it will go from left to the right. First, we'll add the numbers in the 1st digit. It gives you the number 7. And we put 7 in the node. Secondly, we add 4 and 6. So it gives a 2nd digit in our answer. But we don't put 10 here, because from the description, we know in each node the value can be only from 0 to 9. So we have to put a 0 here, and we will carry the 1 into the next digit. So the last step is we add 3 and 4 and 1, it gives you 8. Then we add the node 8 to the linked list. So from this example, we understand the steps to add two numbers will be like this. First, we will have the loop to go through each node in the linked list. We're going to use while loop. So while the list number 1 not equal to null, or list number 2 not equal to null, or if the carry is equal to 1. So here we will have sum equal to the value from the list number 1 plus the value from the list number 2. Plus the carry. So the value for the carry is either 0 or 1. And by default, the value is 0. And the second step in our algorithm is to get the 1st digit from the sum. Get 1st digit from sum. Once we get 1st digit from the sum, we will save the value to our answer. Save it to answer. Just like the example we are using, 2 plus 5 is equal to 7. The 7 is our sum. Then we save the number 7 into our answer here. The next step is to get the 10th digit from the sum. In our example here, 4 plus 6 give you sum equal to 10. We put 0 into a new node, and we put 1 into the carry. So the 1 will be used in the calculation of the next digit. So get the 10th digit from the sum and save it to carry. And the next step is, once we finish the calculation of the current digit, then we will move to the next node. Move list number 1 and the number 2 to the next node. And the last step is, we also need to move the answer to the next node. Move our answer to the next node. So here is the pseudocode we developed from the example number 1. We'll go through the example number 1 again with our pseudocode step by step. So here we have our first number 2, 4, and 3. And the second number we have 5, 6, and 4. And I'll mark this as ones, tens, hundreds. And below the line, we're going to have our answer here. And here we have our formula, the value from the list number 1 plus the value from the list number 2 plus carry equal to sum. In the beginning of the while loop, it's pointing to the node from the left side. So here we have the value for the list number 1 is 2, and the value for the list number 2 is 5. The value for the carry is 0. And it gives you the sum 7. Now we come to this step. Get the first digit of the sum. And the sum has only one digit and it's only one digit. So we save the 7 into the answer. And the carry remains 0. And now we move the pointer to the next digit in the while loop. Now, the value for the first list is 4. And the value for the second list is 6. And it gives you the sum as 10. So our next step is get one digit from the sum. So the way we do to get the first digit from the sum is to use the mod operation. So we're going to do sum mod 10. And here 10 mod 10, it gives you 0. So here we save the 0 in the answer. And next step is to get the 10th digit from the sum. The way we get a 10th digit is to use division by 10. So here is 10 divided by 10, it gives you 1. So we save the 1 into the carry. Put 1 here. I'll move this code somewhere else. Now next step is we'll link the new node to our answer, and we will move to the next node. And also, we keep the pointer in our answer always pointing to the last node. So now, we will do the sum for the 100th digit. The value for the list number 1 is 3, and the value for the list number 2 is 4. The sum will be 8. Then, we'll use these two steps to get the 1st digit from the sum and the 10th digit from the sum. But 8 is only single digit, so there will be no 10th digit. So we only save 8 into the answer. And we link this node to the answer. And we will move our pointer to the next node. So with this example I just showed you, our pseudocode works very well for the addition of the two linked lists. Now because it's only use one while loop, so the time complexity is big O(n). Next, we'll go to the LeetCode website to write and test our code. Okay, this is a pseudocode I prepared in the LeetCode website. We have for loop, then we calculate the sum, then we get a 1st digit from the sum, then we get a 10th digit from the sum, and we move the L1 and the L2 to the next node. Then we move the answer to the next node. Now we implement the code based on the pseudocode we wrote. Okay, first we have a while loop. So here, as long as there is a node in the L1 or L2, or the carry is equal to 1, then we will continue our calculation in the while loop. So while loop will include these steps. We're going to declare an integer sum is equal to L1.value and L2.value plus carry. We'll declare an integer for carry, and the default is 0. In some cases, the length of L1 and L2, they are not equal. For example, if L1 is shorter than L2, when we move the node in L2, L1 reaches to the end. We cannot move L1 anymore. In this case, we want to give a default value to L1. We need to do a null check to the L1. L1 equal to null. If it's equal to null, then we default the value to 0. Otherwise, we will use the value in the L1. We will do the same for L2. We'll check if L2 equal to null. If yes, we default to 0. Otherwise, we use the value in L2. Okay, next, we're going to get the 1st digit from the sum. To get 1st digit, we're going to use mod operation. Sum mod 10. It will give you the 1st digit in the sum. And we will save this value to the new node. Once we create this new node, we will link this new node to the answer. So we're going to declare the answer in the beginning of our function. When we first declare a new node, we will provide a default node as 0. Then we will declare another list node called current. Let current pointing to answer. So this list node will work as a pointer, will move along the answer list node. So it always pointing to the current node in the answer. So let's come back to this step. Then we will have the current node dot next equal to the new node. So by doing this, we link this new node to the answer. Then we come to this step to get the 10th digit from the sum and save it to the carry. Carry equal to sum divided by 10. Next step, we will move the least node number 1 and the number 2 to the next node. So we'll do L1 equal to L1.next. And same thing for L2 equal to L2.next. And the same thing as we did for sum calculation. Before we move to the next node, we need to do a null check. So here we need to check if L1 equal to null. If it is true, then we let it equal to null. Otherwise, we move to the next node. Same thing for the L2. Is L2 equal to null? If yes, we default it to null. Otherwise, we move to the next node. The next step is to move the answer to the next node. So cur equal to cur.next. So here are all steps to create the answer. After we're done with the while loop, we need to return our answer. Return answer. Now, we can't just simply return our answer. Remember, when we first initiate our answer, we assign a dummy node 0 in the head of the least node. So we have to exclude this 0 from our answer. So we're going to return answer.next. So this is the code based on our pseudo code. So let's test our code. All right, our code works. Now let's submit our code. Okay, so it passed the submission. The runtime is 2 milliseconds and is faster than 69% of all the online submissions. So this code has a runtime (2 milliseconds) and it's 69% faster than all the online submissions. Next, we'll discuss another solution for this problem, and we will compare these two solutions, see which solution have better performance. When we work with data structure like a linked list, we usually can develop a recursive solution. For example, if we have a linked list like 1, 2, 3. And in each node, here is the value. The arrow here is reference to the next node. As we can see, it's actually reference to the substructure of the linked list. So next, let's modify our previous pseudocode. See how can we develop a recursive solution from the while loop solution. As we can see from the while loop, there are 3 steps referencing to the linked list value and the next node. So we can combine these 3 steps into answer, value, and the next node. And here, the value is sum mod 10. And the next, we will call add the two numbers recursively for the sublist of L1 and L2. We're going to pass L1 next and L2 next. So here is our step 1. And here is step number 2. And from here to here is step number 3, which links the answer to the next node. And when we call add two numbers recursively, that's equivalent to the while loop. So our new code will be like this. We'll erase the while loop, and we'll erase the number 1, number 2, and the number 3. Add two numbers we'll create a list node answer, and the first parameter will be sum mod 10, and the second parameter we will call add two numbers recursively. And here we will pass L1.next L2.next. So here is our pseudocode for recursive solution. Next, we'll go to the LeetCode website to develop the code based on our pseudocode and test our code. Here is the code we developed for our previous solution. We'll modify on top of it for the recursive solution. For every recursive solution, there is a stop condition. So here, we'll stop our function when L1 and L2 equal to null and the carry equal to 0. So here we're going to have if L1 equal to null and L2 equal to null and carry equal to 0. We'll stop our recursive function by returning null. Next thing, we'll delete the while loop. Next, we will delete the code which reference to the next node. The only two lines of code we're going to use are the calculation for the sum and the calculation for the carry. We move this up. And for the rest of the code, we're going to delete. So after we calculate the sum and the carry, we're going to have a new line for code for the answer. So we'll declare the answer as a list node. We will initiate our answer as such. For the value, we are going to pass sum mod 10. And for the next parameter, we're going to reference to the next node. By referencing the next node, we are going to call add two numbers recursively. And the two parameters we are going to pass L1.next and L2.next. We'll delete the rest of the code. The last step is to return the answer. This is our new code for recursive solution. As you can see, it's more concise than the while loop solution. Now let's test our code. It works. Now let's submit our code. Let's see how well the performance it is. And remember, for the while loop solution, our runtime is 2 milliseconds and is faster than 69% of time. Let's see if our recursive solution can have better performance. The runtime is reduced to 1 millisecond and it's 100%, which is at the top ranking. As we submit our recursive solution in the LeetCode, we saw that the recursive solution works better than the while loop solution. The runtime is reduced from 2 milliseconds to 1 millisecond. The ranking is increased from 69% to 100%. So our conclusion is the recursion solution is much better solution. It performs better and also it only uses few lines of code. Alright, that's all for the add two numbers problem. We end our discussion here. Thank you for watching.